this is a recording on how to plot error boxes. Okay, we have a table here of time and the uncertainty of time. Therefore, it's plus or minus delta t, and the square root of length with its corresponding uncertainty, which is plus or minus delta square root L. Let's say we wanted to plot a graph with square root of L as the x-axis and t as the y-axis. What I'm going to do here is I'm going to copy and paste by placing the data in this position. It makes it easy for Excel to recognize because square root of L is on X position and T is in the Y position, as in the X and Y axis. So what we're going to do now is highlight these two numbers and insert a scatter graph. Okay, straight away you can tell that the square root of L is on the x-axis and time is on the y-axis. And I will now go on to label the axis by turning on the axis titles, yes, and the chart title is already there. So I'll name this chart T versus square root L, and I will label that T with the units of seconds, and axis title here I'll just copy and paste square root of L. And I will copy and paste square root M. And I have to redo the axis title again. For some reason it disappeared. Okay, next I'm going to add the error boxes because we know that the data here all have corresponding uncertainties. Okay, so we'll click on the data point and we will add error bars. Okay, and automatically it's added some random error bar, and now we've got to go and make sure that we set them to the correct values. Okay, so I've gone and highlighted the horizontal error bars. You can see once you've highlighted horizontal error bars, okay, it shows up here saying that it's horizontal error bars, and we know that horizontal error bars are our square root L values. So we click on custom and we want to specify them to the right values, which is delta square root of L, and we can just highlight these, okay, for the positive error values, and we use the same ones again for the negative values because plus and minus uncertainty is of the same values. So let's click on OK, right? So the horizontal error bars are now set to the correct value. Now we have to set the vertical error bars by clicking on it, and it shows up here, vertical error bars, and we click on custom and specify values. And since our vertical error bars are delta t, we select delta t, and the negative values are the same because plus or minus the same values. and click OK. And voila, you have error bars set on your graph. Okay, now we've got error bars. Let's increase the graph size so we can have a better look of what's going on here. Let me just minimize that and increase that a little bit more. Okay, now let's insert a line of best fit into the original data line. Let's click on the original data and right click and add trend line. Okay, and let's add a linear graph, and let's also do a backward intercept so that it cuts across the y-axis. And since we know that the square root of L values start at 0.39, we need to extend it backwards by 0.39 in order to cut the y-axis. Okay, and we also need to display the equation on chart. Okay, so we now have a line of best fit and an equation. All right, so let's label it line of best fit, LOBF. Okay, next we need to put in an error line. And the way we are going to do an error line is that we're going to put two more points in there to show a line going through all the error boxes and to show the steepest possible line that would still fit through all the boxes. Okay, now let's, because we know t is the y value and that's 0.8, we want something that's a bit less than 0.8, and let's try 0.7. Okay, I'm using 0.7 because I know that error is 0.1 and the value is 0.8 for the first point. And the other one, because it's at the end of the line, I'm using 1.9 plus 0.1, and let's use 2.0. All right, and when I click on the graph, right, it shows me, the highlighted part shows me the x-axis values and the y-axis value. And if I were to drag the y-axis value across to these two values, these 2 points show up. Okay, and now I want to adjust the points so that that point there would touch the edge of that error bar, and that point there would touch the edge of the last error bar at the top. So let's shift this down slightly more to say 0.68. Okay, as you can see, the point shifted down slightly, and we will leave it as that. And we can shift that one up to say 2.1. That's gone a bit too far. Let's try 2.02. Okay, and I think that is just right. Next, I want to add an error line that passes through these two orange points. Let's click on the orange point, and we can click either right click or add trend line. Okay, and with that trend line, I will go to more options, and I will set a backward intercept of, as before, 0.39, and I will also add the equation, okay, there, and that is what we need. I'll just minimize that. Okay, so we know that equation there is for the line of best fit since we've labeled it, and let's drag this down over here and call it error line, EL. Okay, so now we've got an error line and line of best fit. We can, if you like, according to yourself, shift these 2 points on the error line to give as steep a graph as you can, so that it gives us a better fit to the maximum error that would still go through all the error boxes. Like for instance, if I were to move this point further up, say to 2.5, okay, that's gone a bit too far. Let's try 2.1. Okay, as you can see, that error line, it's still fitting through all the error boxes, and I think I can even move it a little bit more, say 2.12. Okay, and it still works. And in fact, I could also move the one at the bottom down a little bit, let's say 0.65. Yep. And with error lines in this achievement standard, provided that you show understanding, you don't have to give it an exact fit. Okay, and this video concludes here. Thank you.